Today we're looking at bisectors of triangles. Our objective is we're going to find points of concurrency and use these properties of perpendicular bisectors of the sides of the triangle and angle bisectors of triangles. So let's do some talking about some vocabulary words. If you have three lines and they all intersect at one point, they are called concurrent lines. And then the point where they all intersect is the point of concurrency. So when we're going to be talking about different points of concurrency, our first one is a circumcenter. So we're going to take perpendicular bisectors of each of the sides of a triangle. So if you take a side of a triangle and you cut it right in half and make a 90-degree angle on it, for any triangle, if you do that on each of the sides, all three of those points are going to be concurrent, and they are going to be concurrent. Their point of concurrency is going to be the circumcenter. So that circumcenter is this point P. So if PX, PY, and PZ are perpendicular bisectors, then PA has to equal PB, and that has to equal PC. So we're talking about the length from this point to each of the ends of the triangle is all going to be the same distance long. So all PA here has to equal PB, which has to equal PC. So if you take that point of concurrency, it's called the circumcenter, and the reason that it's called that is because it's circumscribed outside of the triangle. The circumcenter can be inside, on the triangle, or outside of the triangle. So if we look at these triangles, if I have an acute triangle, it would be inside the triangle. The circumcenter on a right triangle will be on the triangle, and a circumcenter will be on the outside of the triangle if it's an obtuse triangle. Now looking at example 1, we're going to sketch the triangles with vertices -4, 2, -4, -4, and 6, -4. If I draw a right triangle, we're going to look for the coordinates of the circumcenter. So if it's a right triangle, it will be on the triangle. So what we're going to do is we're going to cut the two legs in half, and where they connect will hit the hypotenuse of the triangle, and that point will be the circumcenter. So it's kind of like there's a right angle coming out of the point 1, -1. It also, we can have a circle that will hit all of the points, and the center of that circle will be on the circumcenter of the triangle. And notice both of the sides are cut in half. All three sides are cut in half. Now, here is an example. If there's a park manager, and there's some restrooms, a snack shack, and an entrance gate of the park, and he wants to get a drinking fountain that is equidistant from all of these three things. So what we need to do is draw the perpendicular bisector from all the sides, and where those intersect is where the circumcenter will be. This makes right angles on all of the sides of the triangle, and we need to keep in mind that this point will be equidistant from the snack shack, the restrooms, and the entrance gate. So we draw the perpendicular bisectors, they meet at a point of concurrency, and that point is our circumcenter. The incenter happens when we take angle bisectors of all three vertices of the triangle. Now, if we connect the angle bisectors, they will meet at a concurrent point that is equidistant from the sides of the triangle. So this makes a circle inside that is equidistant from the sides. So PX will equal PY, which will equal PZ on this triangle. So we've got an example here of the in-center. The in-center means it's on the center of the circle inscribed in the triangle. And we have an example on example 3. We're going to find the in-center for both 3 and 4. So if it's an in-center, that it's equal distance from all 3 of the sides. So PX and PZ have to be equal. So we're going to set up an equation where we set them equal to each other. We subtract x from both sides and we get 2x plus 7 equals 9. We minus 7 from both sides. 2x equals 2, and so x equals 1 when we divide both sides by 2. Now we're not looking for what x equals, we are looking for what py is. Now if I take x and plug it in for px, I get 10. If I plug x in for pz, I also get 10. So both px and pz are 10, so py also is going to equal 10. On example 4, I'm going to identify the in-center. The in-center comes from angle bisectors of all the triangle. So I've got 2 of the angle bisectors, and they intersect at point Y.